What are slope fields? A slope field is a graphical representation of all possible solutions to a differential equation. In other words, it is a graph of the slopes of a function at different points. After graphing the slope field, we can visually understand the family of functions who share the same derivative. Small dash marks are used to represent the slope at each point on the graph. These slopes vary based on the ordered pair used, but sometimes patterns arise depending on the differential equation. Why are there so many dashed lines? As you can see in the graph in the center of your screen. Remember, there are an infinite number of functions who share the same derivative, depending on which constant is added. The slope field represents the entire family of functions who share the derivative. Example number 1, slope fields. Sketch the slope field for the following differential equation. dy dx is equal to negative y over x. What we do is we start by substituting different coordinate values into the differential equation and make a dash mark to represent the slope at each point. I'll use a yellow highlighter for the first one. At the point 2, 1, I replace y with 1, x with 2, and I get the slope of negative 1/2. So when I go to the point 2, 1, you'll see right here is a dash mark that has a slope of negative 1/2. The second point I'm going to look at, and I'll highlight that in green, is negative 2, 0. When I replace the coordinates negative 2 and 0 into their respective x, y values, that gives us a slope of 0. So I go over here to negative 2, 0, and you'll see a dash mark that has a slope of 0. The third point I'm going to consider is negative 1, negative 2. And when I replace those points into the respective places in the equation, we're going to have negative 2 over negative 1, which gives me a slope of negative 2. Don't forget there's a third negative right here. So my ultimate slope is going to be a negative 2. And when I go here to the point negative 1 over negative 2, there's my slope of negative 2. And finally, if I consider the point 0, negative 1, I'm going to get an undefined slope. So when I go to the point 0, negative 1, here you see a dash mark that has an undefined slope. What you would do is continue to find the slope at various points until you have completed the slope field. Example number 2, slope fields. Sketch the slope field for the following differential equation. dy dx is equal to x. To do this, we substitute each ordered pair into the equation to find the slope at the point, and each dash line has the slope of the function y at that point. The differential equation is only in terms of x, and therefore all the points with the same x value result in the same slope. I'll do a few concrete examples for you. If I choose the point 0, negative 3, I only replace 0 into our differential equation and obtain a slope of 0. If I use the point 0, negative 2, I also obtain a slope of 0. Using the point 0, negative 1 and substituting 0 in for x also gives me a slope of 0. And using the point 0, 3 also gives me a slope of 0. So when I look at my graph and I go along the line x equals 0, you'll notice all these dashed lines have a slope of 0. Continuing this out, if I were to go along the line x equals 1, all of these slopes, these little dash, have a slope of 1. And if I go to the left, along the line x equals negative 1, all of these little dash lines have a slope of negative 1. Example number 3, slope fields. Sketch the slope field for the following differential equation. dy dx is equal to negative x over y. To do this problem, we substitute each ordered pair into the equation to find the slope at that point, and each dashed line has the slope of the function y at that point. Let me give you a couple examples to follow. If I consider the point -3, 1, and plug it into our differential equation, negative x over y, we attain a slope of 3. And when I go over to the point -3, 1, here I have a dashed line with a slope of 3. If I consider the point 0, 2 and plug it into the differential equation, negative x over y, I obtain a slope of 0. And when I look at the point 0, 2, here I have a dashed line with a slope of 0. And I would continue that concept throughout the entire graph to generate a slope field.